Good morning, student. Good morning to all of you. Myself, Suraj Kumar Soni, and today we are going to start a new chapter, chapter number 11, Work and Energy of class 9th, subject Science. Okay, and in this chapter, we will study about some introduction part of the energy, and then what is energy, form of energy, and type of energy, in which we will study about kinetic energy and potential energy, especially then law of conservation of energy, then point number power, then commercial unit of power. These topics we will do study in this video. Now start. First, introduction. First, what is the meaning of work? What is the meaning of energy? In day-to-day life, we considered any useful physical or mental labor as work, which is being defined differently in the science. Two conditions are need to be satisfied for the work to be done in the science. First thing is that a force should can be act on or object. How you can determine the work is going on? First point is a force should be act on the object. You should have to apply the force on the object. Point number second, the object must be displaced. Okay, means the object must change their position. Okay. Point number third, if either of these conditions does not satisfy, we say work done is zero. If there is no displacement, if there is no force applied on the object, then we can say that there is no work. Okay. Then work done by the constant force. We define the work. But then what is the meaning of work? The definition of work and the formula of the work is equal to force into displacement. Means W is equal to Fs. F means force, S means displacement. Okay. Now work done by the 1 Newton force is displacing the object, and 1 meter will be the in the 1 nanometer, Newton per meter. Unit of work is Newton into meter or joule. We can say that there are two terms, force and displacement. Unit of the force is Newton, and the unit of the displacement is meter. Displacement means how much distance we have covered, that is called displacement. Then the work is equal to force into displacement, so you can say that when the 1 Newton work is displacing the object in the 1 meter, then you can say that the work is 1 Newton into meter, or you can say work is joule of 1 joule. Now if displacement is the direction of the force, work is a scalar quantity. Okay, there are two quantity, scalar and vector quantity. Scalar quantity required magnitude with direction, vector, and the uh, vector quantity required only magnitude, no direction. So it has only magnitude, no direction. So you can say that there are two quantities, scalar quantity and the vector quantity. Vector quantity require magnitude and direction, but the scalar quantity require only magnitude, no direction. Okay. So work is a vector, a scalar quantity. It does not require any directions, so means you can do the work required in any directions. Next point, if displacement, the next point is that if displacement is in the direction of the force, then work is taken as the positive. For suppose, for example, if you push a bucket or a box in the right direction and the object is going to right direction, means the work is positive. If you push the object in the right direction and the work and the displacement is occur in the left direction, means the work is negative. Okay. If displacement is in the opposite direction of force, then work is the taken as a negative. Okay, that is the work. So you have to know the formula. The formula of the work is equal to force into displacement, Fs. Okay, so unit of the work is Newton into meter, or you can say joule. Now energy, what is the meaning of energy? An object having the capability to do work is said to be process energy. An object having a capability to do work is said to process of energy. The object which does not lose energy and in accordance with the law of the conservation of energy, and the object on which work is done gain energy. Okay, when work is done by the object, then it lose the energy. Then work done on the object, it gain energy. The energy possessed by an object is thus measured in terms of the its capacity of doing work. How much work is doing means how much energy is losing or how much energy is gaining. Okay, the unit of the energy is therefore the same as that of the work. So the unit of the energy is joule. You can say that work is equal to energy. You do the work according to your energy. Means if you have 50 joule energy, then you can do 50 joule work. Means energy and work are both are same. So the unit of the energy is joule. Okay, now form of energy. Different type of energy you see in your daily lives. First, there is a trick. The trick is melt. melt, melt. You know, the any chocolate is like start to melt when you put in the sunlight. Okay, that is called melt. Melt. M means mechanical energy, A means electrical energy, L means light energy, T means thermal energy, S means sound energy. Okay, mechanical, mechanical energy, electrical energy, light energy, thermal energy, and sound energy. These are the type of energy. Now form of energy. Okay, form of the energy. These are the form of energy, and this is a type of energy. Now mechanical energy is can be divided into two types. The most important thing, first one is the kinetic energy, and second one is potential energy. There are two type of the mechanical energy. Now we have to, in your chapter, mechanical energy is given in deep process. Means kinetic energy and the potential energy is given in very deep process. First one is the kinetic energy. It is the energy process. Kinetic energy, kinetic means movement by the motion. Means energy is provided or energy is generated by the motion, that is called kinetic energy. It is the energy caused by the object due to the motion. Okay, derivation of the kinetic energy is, we know that F is equal to ma. Okay, F is equal to ma. This is the formula of force, mass, and acceleration. Look at that. F is equal to ma, where m means mass. Okay, mass, and a means acceleration. Okay, acceleration. So, and we know the formula of the velocity, v square minus u square is equal to 2s. Okay, or you can say that v square is equal to v square is equal to u square plus 2as. This is the formula of velocity, motion. And if body start from the rest, then 0, u is equal to 0. U is the initial velocity and v is the final velocity. If the body start from rest, then u is equal to 0, and v is equal to 0. So you can say that v square is equal to 2s. By definition, the kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it the acquire that velocity. Okay, ke means kinetic energy is equal to fs. So we can say that the formula of the kinetic is equal to kinetic energy is work into displacement, w into d. Then w is the formula, w is fs, means fs. Okay, the formula of the f is f is equal to ma. So there is m is given, and s means velocity displacement. The value formula of s is v square upon 2a. So we get the value of kinetic energy is equal to 1 upon 2 mv square. That is the formula of the kinetic energy. Or you can say like that, kinetic energy formula is kinetic energy is mv square upon 2. Okay, this is the formula. Now shift to the next point is potential energy. I think you understand very well. If you have any doubt, you can ask. Potential energy, kinetic energy means this energy is generated by the motion, but potential energy means this energy is generated by the stationary position, change in the position. The energy produced by the object by the virtue of its position or the configuration is called the potential energy. Potential energy is a relative term. You can choose reference position where it is 0. Okay, an object energy increases when it is raised through a height. This is because work is done on its against gravity while it is being raised. The energy present in such an object is the gravitational potential energy. The gravitational potential energy of an object at a point above the ground is defined as the work done is rising is from the ground to that point against gravity. Now, this is the formula of the potential energy. Potential energy equal to PE. Potential energy is equal to mgh, where m is the mass, g is the gravitational energy, or h is the height. Okay, M is the mass, unit of the mass is kg, okay, or you can say gram. And gravitational force, G means gravitational force, the value of the gravitational force is 9.8 meter per second square. And H means height we can take the height, the value in the meter, okay. Now, work done देखा तो by the gravity depend only on the vertical height differences of initial and the final positions. The formula of the potential energy is mgh, where m is the mass, g is the gravitational force, h is the height. In both the cases shown, wd is same, thus the potential energy is high. E is equal to mgh and E is equal to 0. At 0 position, the potential energy is 0. At high position, potential energy is high. Okay, I think you understand very well. Okay, now we have to know next topic is law of conservation of energy. How you can conserve the energy? Just look at that. Now, law of the conservation of energy. How you can conserve the energy? Okay, the first term is that conservation of energy. Energy can neither be created nor be destroyed. Means the term is that energy can neither be created nor be destroyed. It can be converted to one form to another form, but total energy remain constant. This is the simple law of conservation of energy. Now, the first diagram showed that K is equal to maximum, means kinetic energy is maximum when potential energy is 0 due to the motion. In second terms, at the height, potential energy is maximum but kinetic energy is 0. At the middle point, kinetic energy and potential energy both are not equal to 0. And okay, the sum of the kinetic energy and the potential energy is called mechanical energy. Means you can say that mechanical energy is equal to kinetic energy plus potential energy. Okay, this is the formula. Now move to next slide. What is the power? What is the meaning of power? Power is defined as the rate of doing work or rate of transfer of energy. Rate of doing work, that is called power. The simple definition of power is defined as rate of doing work. How much work we can do, that is called power. Okay, if a body does a work in time t, okay, if the body does a work in time t, then power is the given by P is equal to W upon T. P is equal to W upon T, means how much work is done by the object in a given particular time. You can say definition is how much amount of work done by an object at a given particular time is called power. So unit of the power is, unit of the work is joule, and a time unit of the time is second. So you can say that unit of the power is joule per second. Okay, joule per second. Average power is equal to average work upon average power. How we can determine the average power? Average power is equal to average work upon average time. So this is the definition of power, and this is the most important formula of power. Now shift to the commercial unit of the power. How we can commercial unit of the power? One commercial unit of the power, 1 kilowatt means 1000 watt into 1 hour, or you can say 1 hour means 3600 seconds. So 1 kilowatt is equal to 1000 watt into 3600 second, and 1 kilowatt you can also say that 3.6 into 10 to power 6 joule. This is the unit of the commercial conservation of unit of the power. 1 kilowatt, 1 kilowatt per hour means 3.6 into 10 to power 6 joule. 1 joule is very small quantity. Okay, the energy used in householded industries and commercial establishment are usually expressed in the kilowatt hour, means 1 kilowatt hour. Okay, when we use the energy at our home, industries, factories and commercial establishment, the unit of the energy is kilowatt hours, kWh. 1 unit means 1 kilowatt hour. Okay, you just see your electric meter, you see the bill come in, units come into the kilowatt hour. Okay, just see the electric bill, that is the consumption unit is a 128, so 128 kilowatt hours. Okay, now we have finished this chapter. This chapter has a very some this point, and then we have done it. So you have to read this, see this video again and again and learn it. Okay, now now it's time to solve the question. The question number first is, how we can determine the work is done. Question number first, how we can determine the work is done. Question number second, define the work with the formula and the unit. Define the work with formula and unit. Question number third, what is energy? Question number four, what is the unit of the energy? Question number five, write any three difference between the kinetic energy and the potential energy. I think you do very well. Okay, in these terms you have to write the definition and unit and the formula. Question number six, define the power with unit. And question number seven is, what is the value of the 1 kilowatt hours in joule? You know very well, 3.6 to 10 to power, okay, 10 to power 6 joule. Now uh, thank you so much for watching this video. See this video again and again and learn, okay, and make the notes and do the work at your homes. And this is your homework, very important for you. You have to do in your notebook. It will be checked after school reopen. Thank you so much watching this video.